So let's talk about this ASCII one. This is pretty simple, greet.asm. All this is going to do is write a prompt, then read data from numbers, and then print it out. It's going to combine two numbers. It's going to combine two things. So this is going to take your name plus ECX, and it's going to make a loop. Yeah, loop next character. Now the loop command, let's take a look at the tutorial and learn about the loop command, because this is very handy. If you go to the tutorial, which is right here, there we are. If you go to the tutorial, there are loops, and there they are. So you can do loops yourself. You can you can take a register and put in a number and then increment it and see if it's 0. But there's a special command, series of loop commands, loop label. The loop instruction will always use the ECX to have the loop count. So every time you execute loop, it will go back to the label and decrement ECX. And when ECX is 0, it's done. So that's an easy way to do something a certain number of times. So this one, I want to print a whole string that came in a variable length. So here, I read this thing, I read your name, and then I'm going to move characters one by one here. So here's the loop, goes to the next character, it's going to jump back here. So up here, I calculate the length of what I want, adding EDX7. I start with EDX to be the location of hello, then I move forward by 7, so I keep hello, comma, space, and then I start adding your name after that into the string. If you look down here, I have hello, and then I have this room to put in your name. So this loop is going to fill in your name byte by byte there. And so that's going to the next character. So I move that into EAX. I move into EAX EDX plus ECX, ECX being my counter, which is starting at the length of your name. So it's going to do it from the right. It's going to start at the full length of your name and then decrement it to character, 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 character until it gets to here, filling in your name. And then I decrement EAX and EBX, and move that to here, and then loop to the next character. So that's the idea. And so that thing, let's see if this one works. I think it'll work. Just an example to show a few more tricks. That's greet.asm. All right. And compile it, which is, there we are, greet. All right, something wrong with 23. Oh, I remember. This is something a student was talking about. It won't take that, which is weird because it did when I did it before. So what I did was, I don't know why it won't let me do this, move EBX the sum of two registers, but since it won't let me do it, I'll put EDX in there, and then I'll add ECX, which will amount to the same thing. And if you use ARM code, this happens to you a lot, because ARM is a reduced instruction set command, so a bunch of the complicated commands are not there. Everything gets very simple.
Can you put a parentheses for that gap there?
Parentheses? No, I don't think you can use parentheses at all, and I don't think it would work. I could try it, though. Let's try that since I'm here. If I do plus, I don't think you can even use parentheses here. I've never used parentheses in assembler. Let's try it and see. I don't think so, because this implies it's going to do that first, and that means two commands in one line. I don't think this low-level language can allow you to do that at all. Yep, it still doesn't like line 23. Yeah. See, that's a high-level language trick. Using parentheses implies do a certain operation before you do this operation, and you can't do that in assembler. You can only do one thing at a time, and it has to match an instruction hardwired into the processor. So, by the way, let's show why that didn't work. If I do the x86 assembly operations and add, All right, here's the add instruction. Here's one, and here's the x86 instruction set reference. Oh, I better use Intel. I guess x86 will tell you about that. Okay. So what you can do is you can find out what adds exist. Here you are. Here's a list of them. So you can add various things, but you can't add the sum of two things over here. You can add a register 32, immediate 8, immediate 32, immediate 8, but nowhere can you have the sum of two things over there. That's why it didn't work. That command is not available. There are 10,000 assembly language commands in, and here's, yep, there are 10,000 commands available in the processor, but that one does not exist. Yeah. You can't add two registers, and nope, you have to do it one step at a time, even in Intel. And in ARM, what's that?
Register in the number you can add.
Yeah, it can add register number. You can also, I think you can also address memory, which is strange. I'm not seeing it here. But anyway, that's, yep. And by the way, if you use ARM, it's going to be even less. ARM add instructions. ARM instruction set. I don't know if I'm going to be able to easily, yeah, it's going to be too annoying. ARM. Anyway, when I do ARM, ARM has an even smaller instruction set. So anyway, that's what happened. Good. So now I should be able to compile this one. There we are. Now link it. Greet. And now run it. Good. And see, it only goes up to some maximum. And it got an H somehow, so I don't quite know what caused that. Let's try a shorter name. It didn't work too well even on the shorter name. There's some kind of problem with the early characters in there. So there's another bug we could track down in that program, but it's doing part of it right. All right, looks like it's not calculating the length of this input correctly and starting in the wrong place. But anyway, that's a start. All right, and so let's just talk about debugging. Might be as far as I want to go with this today. I'm not sure. We'll see. Yeah. So you can debug your assembly code. Of course, as a matter of fact, it's kind of obvious that you want to debug it. Debugging should take you back right where you started. So if you have your hello here, and so you can just debug it with GDB, the GNU Debugger, -Q. In this class, we've only used Windows debuggers like Ollie. But the Linux debugger, there's a bunch of them. But this is the best one, the GNU Debugger, the original one. It's command line only, though, so you have to get used to it. But there's a few commands that are pretty obvious, like disassemble from a start point. Okay, good. So I found a tutor site, which is good. Thank you. All right, and so here, I've just disassembled the code at the start, and that should match my original assembly code, move EDX length, move ECX message, and see, it seriously doesn't. And there's two problems here. For one thing, things like message have turned into explicit numbers. And things like length have turned into explicit values. Another thing is these are backwards. And you may remember this in like one of the early chapters. There's two syntaxes for assembly code just to make sure that you're always insane. One works with the source to destination here, and the other works the source here and the destination there. And this is using the other one. So you...
The AT&T standard.
What?
The AT&T standard.
Yes, AT&T instead of, I think, Intel.
It's Intel, yeah.
Yes, so here's how you get there. You set disassembly flavor Intel. You can do it the other way, and then disassembly start. Then you will see the standard way you're used to seeing Windows assembly code. So now it's move EDX to length, move ECX to somewhere, move EBX to 1. Now, so let me get my summary of the changes here. All right, so EDX contains 0C. Right, okay. Anyway, so now we're going to try debugging it. So we're going to put some breakpoints in here now that we've found it. Here we are. The constant length was resolved to its value of 0C. In my case, it's 0E, which is a little strong. Oh, because I added the carriage return line feed. So my string is a little bit longer, CDE. And then here, EBX, the address of the string appears in hex format. That's going to be in the data section. And the other lines are exactly as they appeared in the source file. Okay, good. So now we'll put in some breakpoints. See, here you can see this is start plus 10, and this is start plus 15. So I can break at those points by doing break, start plus 10. And I can put a breakpoint here at start of 10 plus 15. And we're used to breakpoints from Ollie debug and so on. So if I run, it's run. It hits the first breakpoint. Now I can do info registers. And at this point, I broke here. So it's moved something in EDX and ECX. It's put a C in, or E, in my case, in EDX. And then it's put a constant in ECX. And it has not yet put 1 in EBX. So it's just got whatever's left over there from before. So that's where we are. All right. Now if I continue, it will go to the next line, and that will put the 1 in EBX. So info registers will show that. So did I say this is the command line version of the more convenient graphical tool in Ollie, and there are people that have attempted to make similar graphical tools on Linux, but I've never thought it were worth anything. But I'm used to using headless terminal-only Linux servers. So command line is what I'd rather have for that case. Anyway, now you can look at memory segments. Remember, you can look at the memory window in Ollie and see the segments. You can do the same thing here with info proc mappings. And there they are. Let me make my window a little wider so it's... All right, so there's a stack up here, and there's 2 sections called to this, and one of these is the text section, and one of these is the data section, I think. But you can't tell which one is which. It doesn't label them for you here. But that's a start. And so anyway, now there are some various flags to find here, and you can do a little bit of debugging with this thing. And if you take the malware and the exploit development class, half of the class is using this tool to develop exploits. So you get good at using GDB. GDB is very complicated, has dozens or hundreds of commands. Here you learned about 2. In the exploit development class, we use about 7. That's as far as I ever went. Same thing is, by the way, true of Ollie debug. Ollie debug has another 100 commands. I've only learned to use 4 or 5 of them. But anyway, all right. So that's the that's it for that stuff. All right, let me stop this recording. Well, I think I'll say a word about this files one. Yeah, this is just how you write to a file. You create a file with with the kernel call 8, syscall 8. You create a file with a file name and permissions, and then you can write to that file. So it's going to return in EAX a file descriptor that you can put in FD, and then you can put it in EBX and write to there, just like you write to anything else. So you can write to a file, and you can read from a file, just like you write from standard input and write to standard output and read from standard input. That's the whole point of Linux. Everything is a file. The keyboard is a file, the screen is a file, everything's a file. That's the whole logic of Linux. So once you learn how to read or write from anything, it's exactly the same process to read or write from anything else, which is nice. So I think that's all of this I wanted to cover, unless questions bring up other things to say.